Ecoholics. So this is a series where I have been doing previous year questions from DSE. So in today's video, I'm going to do a previous year question from the paper 2019. So let's just see the question. It's question number 16 from 2019 paper, which reads that a consumer lives for 2 periods, 1 and 2. The lifetime utility function is given by this thing. This is a function. The consumer earns W1 and W2 in 2 periods. That's the income of the consumer in 2 periods. And her consumption C1 and C2. That's what he consumes in the 2 relative periods. Satisfies a lifetime budget constraint. So we have a lifetime budget constraint. That is C1 plus C2 equals to W1 plus, okay, so C1 plus C2 upon 1 by R equals to W1 plus W2 upon 1 by R. So because we are dividing this by 1 by R, so that we can have its present value. Assume that utility C1 is equal to this thing. So this is the utility function. So they have given us this form for the utility function, which stands true for both the periods. Then they ask that if R is greater than or equal to rho, so what happens? So R is what? R is the rate of interest that person is getting, and rho is the rate of discount. So at what rate of discount he thinks about his future consumption. So that's the thing. So what happens if R is greater than rho? So if we can consider this thing that if I'm getting more higher rate of interest in future, I would definitely save today so that I can earn a good rate of interest and I can consume that income in my future. So that's a really straightforward thing. But because they have given us this thing here, so they have given this utility function, so maybe there would be some little tricks in this or something else. So let's just see, is it the same thing we are gonna get? So we will have to do it mathematically to just check our answer. So this is the information given to us by question. So how will I do it? So the main objective of my consumer is to maximize their utility subject to a lifetime budget constraint. So I will write the Lagrange where I will be writing utility function, this one, plus Lagrange multiplier and my budget constraint. So I will be getting W1 plus W2 upon 1 plus R minus C1 minus C2 upon 1 plus R. So I do this thing. Then my next task is to differentiate this with respect to C1, with respect to C2 and with respect to Lagrange multiplier. So let's just differentiate it with respect to C1 and C2. So if I will differentiate it, I will be getting derivative of utility function which contains the term C1. So I'm not substituting this thing because this is a little tricky, difficult form of the utility function. So instead of writing its derivative here, because we just want to find the result, so we can substitute it later if we need it. So that's the thing. This will become 0 and then lambda C1 ka we have only one term, so minus 1 equals to 0. So from here I get lambda equals to utility derivative of C1. If I do the derivative with respect to C2, what I get? I will get the derivative of my utility function containing the C2 upon 1 plus rho. That's a constant, so it will be the same. Plus lambda with respect to C2. So what do I get if I do it with respect to C2? I will be getting minus 1 upon 1 plus R. I will be getting this thing. That's also equal to 0. So from here I can write that alpha is equal to U dash C2 upon 1 plus rho into 1 plus R. We can do that. So that's the thing. So from this equation and from this equation, I would equate I would equate lambda. So let's just see that. If I divide both of them, what do I get? I get U dash C1 upon So because I'm dividing, it's even better to keep 1 by r here. I tell you why. So let's just do that. So if I divide it, I get u dash c1 upon u dash c2, this is c, upon 1 plus rho. So here I get lambda in this side and here I get lambda upon 1 plus r. So lambda gets cancelled out and I'm gonna left with u dash c1 u dash c2 equals to 1 plus r upon 1 plus rho. So we have got this relation between the marginal utilities. So we know that whenever r is going to be greater than or equal to rho, what will happen? What will happen if r is gonna be greater than my rho? Then my utility C1 will be greater than utility C2. So that will happen. So if this is gonna happen, then next what? Then it means C2. So marginal utility, what happens? So if the derivative is greater, so just a second. So now I can say is that the derivative, that the marginal utility of my first period, that's greater than marginal utility of my second period. So according to the differentiation rule, my C2 will be greater than C1. So my C2 will be greater than C1 because maximization happens when the slope is falling, right? So it means C2 is greater than C1. So it means that whenever R is greater than rho, my consumption in second period will be greater than or equal to my consumption in first period. And that's happening because you will save in the first period so that you can consume more in the next period of yours because you're getting a higher rate of interest. So I will go with option number B. So B is my correct option, which says that C2 is greater than C1. So this was the solution to question number 16. If you want to see more such solutions, please like, share, subscribe to the channel. Thank you everyone.